Hello everyone and welcome. I'm Dr. Judith Gentle and I am a senior lecturer at the University of Surrey, where I lecture in developmental and cognitive psychology, and I teach perception in those two topics. And I also teach neurodevelopmental conditions, where I talk about DCD. Today we're going to take a short journey into how our brains interpret and perceive the world and what happens when those interpretations don't quite align with reality. We'll be using DCD or dyspraxia as our lens to help understand perception. And by the end, I hope you'll see that what we see isn't always reality. So just a little bit about me to set the scene. I am both a researcher and a parent of an adult with DCD. So this topic is close to both my professional and my personal heart, and I use information from one to inform the other. My research focuses mainly on adults, where I look at how movement, coordination and perception can interact with education or social, emotional or even health outcomes. I also run at the Movement, Development and Impact Lab, where we study how motor skills shape learning. They can affect social skills and well-being. In this mini session, we're going to be exploring how the brain integrates sensory information to understand the world, how perception and movement work together, and what happens when that integration goes wrong. For a little bit of fun at the end, we're going to ask you to take part in a small interactive activity so that you can start to get some of those experiences yourself. And this session will prepare you ready for the next session, which is going to take part on the 13th of November. Okay, so let's start with the basics. Firstly, I just want to give you some definitions before we go on, because I may talk about these things a little bit. So sensation is a passive activity where we're bringing in sensory information from the environment into our brain. And perception is an active process of being able to interpret that information. So for example, you're listening to me talk and you can't not hear me, unless of course you turn the volume off. But you may not, if I'm not speaking a language that you understood, you may not know what I'm saying. So that's kind of a nice example of the difference between sensation, which is hearing the noise that I'm making, and perception, where understanding the words that I'm talking about. And then the other area I just want to talk to you, another definition is multimodal perception, which is where we use sensory information from a variety of different modes, such as vision and audition, which is hearing, so that you can understand what's going on. So I'm just going to describe this picture here to you. When we're talking about movement, we often need to integrate information from these three modalities. So vision, we need to be able to see where we're going. Our vestibular system, which is held in our inner ears, is our balance system. So when we're walking around, we need to be able to keep balanced. And then we have our proprioceptive system, where we need to be able to know where our joints and our bodies are in relation to ourselves and to others. So one of the things that we want to talk about is, as I was talking earlier, that you can't not hear what I'm saying. But our senses don't work on their own, they work together. And it's quite clever, really. As we know, light travels faster than sound. So you are seeing my mouth move, and you're receiving that information sooner than you're receiving the information from what I'm saying. But somehow in our brains, we are able to put that together, and you are hearing and seeing the information, and you're seeing it as one thing. So you can hear a perfectly clear, synchronized message. And that's sensory integration, and it's essential for navigating the world effectively, and it allows us to make sense of really complex environments. And that's perception. Okay, but our brains aren't just always accurate. Our brains don't always just record reality. We also have to interpret what we're seeing. And what you can see here is that we combine what we're seeing, the information that we're bringing in, but we also impose our past experiences on that. So if you look at this Muller-Lyer illusion, you may well have had experience of this with your chemistry, with your psychology A levels, but you can see two lines here. one of which has an arrow junction and one of which has a fork junction. And it may be to hopefully most of you that one of those lines looks longer than the other. But actually what we can see is that they are identical in shape. So we're using our past experiences to influence how we see the world. And this happens many, many illustrations that you'll see. Why is it, just as a question for you to think about, and we may discuss next week, why is it that you think we perceive these lines differently? Why does the brain do this? Why does the brain make these assumptions? Okay, so also, whilst we're making that with a perfectly able to see the information and to interpret the information, we're still making mistakes. We can also make mistakes if our brain doesn't integrate the information smoothly. So as I said earlier, in order to move, our systems need to be able to integrate our vision, our vestibular or balance systems, and our proprioceptive systems, where we are in space and our joints here. So if you can imagine this picture, looking at the man picking up the box, I was trying to get this to show that he was expecting the box to be a lot heavier than it actually was. And if you've ever done that, if you've picked something up and it's a lot lighter, it may well affect your balance. And you may get some sensory information that hindered your predictive control, as we call it. So your sense of balance didn't quite work together. So then you see when these systems don't really line up, there are even tiny errors can have big consequences for you. And, you know, some people may fall over in that kind of particular incidence. So we can just break down this a little bit further. The visual system, which is really important for informing our movements, it has two main pathways. It has the dorsal stream, which helps locate objects and plan movement, and you can see the dorsal stream moves from the occipital lobes, which is right at the back, so the information from our eyes goes from our inside into our eyes, and it goes right to the back of the brain, and then it's distributed to all sorts of different areas. So the dorsal stream goes up here, as you can see, and to the parietal cortex here in the pink, and the ventral stream, which helps identify objects, goes down to below to the ventral streams here. So as for smooth action, these two streams must communicate. And in DCD or dyspraxia, these integration can be disruptive, which means that it's difficulty processing the visual information to guide movement. For example, things like catching a ball or writing neatly or navigating through a crowded space can be difficult for individuals with DCD. So when visual information doesn't align with proprioceptive feedback, that's when the body's internal sense of position and movements does feel a bit uncoordinated and unpredictable. So this brings us nicely on to dyspraxia or DCD. I will use the two terms together. DCD has diagnostic criteria, but dyspraxia is often the term used within the main world. So as you've probably noticed already, I kind of use the two terms intermittently, but usually I will be talking about DCD. So DCD is essentially, I've got all the details on there that you can read while I'm not here, but it's a lifelong neurodevelopmental condition that affects motor coordination. But also it's a very poorly recognised in many environments, and it tends to, as individuals with DCD are often perhaps their behaviours are often misattributed to lack of motivation or laziness. But it's a very high prevalence rate, as you can see here. So it's as common as dyslexia or ADHD, and it's more common than autism spectrum conditions. But there's very little known about it, so that's why I'm so passionate about researching it. But it also involves other areas such as perceptual processing. And as we've talked earlier, it's difficult for individuals with DCD to integrate their visual information with their movement information, and this causes issues when they're moving around the environment. So what does this look like in daily life? You might notice that one of your peers or a student is bright, is articulate and creative, but may struggle or avoid tasks like writing, sports, or managing everyday routines. They might seem a bit clumsy. They might avoid activities that require fine coordination, like I said, like writing. These don't tend to affect effort. They don't reflect effort or intelligence, but they stem from how their brain integrates sensory and motor information. Simple tasks like tying shoelaces or carrying a tray around a busy restaurant or changing for PE can become really important senses of frustration, anxiety, and really starts to affect people's self-esteem. Understanding these things helps us support these students, focusing on their strengths, and allows them to equitably engage in society. So finally, just drawing to the end of my 15 minutes here, just let's move on to the interactive element, which hopefully you'll be able to complete before the main session on the 13th of November. So this is a small at-home task to help you experience what it's like when perception and movement don't really align very well. So you'll need a sheet of paper, a pen, and a mirror. Well, I think you can get, if you use your camera as well on your phone, you can use that. So please, what I'd like you to do is to hold the mirror beside the paper in your dominant hand. So with your right-handed, so it will be with my right hand. I can't really show you on there, yes. And then you need to get a pen and hold it with your non-dominant writing hand. And then I want you to write the sentence that you can see here. The quick brown fox jumps over the lazy dog, but only looking in the mirror while you're doing that. So what I'd like you to do is to do that task, but also I'd like you to think about the task and how it makes you feel and how it makes you behave, so that we will discuss this in more depth when we meet for our interactive session.